Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is complex numbers. In this video, we'll be focusing on the NCERT solution to the miscellaneous exercise problems. In the first problem, we need to evaluate I power 18 plus 1 over I power 25 the whole power 3. So how do we solve such problems? First, we'll convert the odd powers to even powers, lowest even integer powers. So how do we do that? And even powers will retain as it is. So I power 18 can be written as I square power 9 and I power 25 will be written as I into I power 24. And I power 24 can be written as I square power 12. Why we are doing like this? Because we know I square is equal to minus 1 and to their power can be easily deduced. So we write I square power 9 as minus 1 power 9. Here it will be I into minus 1 power 12. This will remain minus 1 and this will become plus 1. So this will be minus 1 plus 1 over I power cube. To remove I from the denominator, we multiply both numerator and denominator for this expression alone as into I and divide by I. So denominator will be I square, which will be minus 1. So this in turn will become minus 1 minus I the whole cube. We want to take minus 1 outside so that this will become 1 plus I the whole cube. So when we take minus 1 outside and here it is cube, so it will be minus 1 power cube. So now we expand 1 plus I the whole cube, which is 1 cube plus I cube plus 3, 1 into I into 1 plus I. I cube again can be written as I square into I and I square is minus 1. If we simplify like that, we'll get the expression minus 1 plus 2i plus 3i square. Again here I square is minus 1. So this will be minus 3. 1 minus 3 is minus 2. So keep simplifying, we get the expression 2 minus 2i. This is the final answer. In this problem, for any two complex numbers z1 and z2, prove that what is RE, real part of z1 into z2 is equal to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2. So how do we prove this? We take two complex numbers. Assume any two complex numbers z1 and z2 as x1 plus iy1 and z2 equal to x2 plus iy2. Let us find the RHS first. So real part of z1 into real part of z2. Real part of z1 is x1, real part of z2 is x2. So this will be x1, x2. That's what we have written here. Minus imaginary part of z1 is y1 and imaginary part of z2 is y2. So this will be minus y1, y2. So we got the RHS as this. Now we will compute the LHS and try to equate it to this. So let us multiply first z1 into z2. So that is x1 plus iy1 into x2 plus iy2. So we can open bracket. So x1 will multiply x2 plus iy2 and iy1 will multiply x2 plus iy2. So now we open up the bracket. This will become x1 x2 plus x1 y2 plus iy1 x2, and here we'll get the I square term, which is minus 1. So this will become, this expression will become minus y1 y2. So the real part of this will be x1 x2 minus y1 y2, and this will be imaginary part. We need to get the real part of z1 z2. So z1 z2 we already got as this expression. The real part is x1 x2 minus y1 y2. This is what we got in RHS. Hence it is proved. In this problem, we have to reduce this expression 1 by 4 plus I minus 2 by 1 plus I into 3 minus 4i by 5 plus I to the standard form. What is standard form? a plus ib or x plus iy, these are the standard form of the complex number. So we have to reduce it to this form. How do we do it? We will first solve this expression in the first bracket by taking the LCM. That is simple mathematics. So denominator will be 1 plus I into 1 plus 4i. We will do cross multiply and simplify this. The other one, then we multiply 3 minus 4i by 5 plus i. When we multiply, we know that I square is minus 1. When we simplify this, we get this as 33 plus 31i by 2 into 14 minus 5i. But we have to put in the standard form. This is not in the standard form because denominator I term is there. So we rationalize this. Rationalize means we multiply both numerator and denominator by 14 plus 5i. That is the next step. So multiplying both numerator and denominator by 14 plus 5i. So this will be a square minus b square. A square is 14 square is 196 minus 25i square. I am talking of the denominator part only. And I square is minus 1. So this will be 196 plus 25. Now we multiply each term like 33 into 14 plus 5i and 31i into 14 plus 5. We keep multiplying and putting I square equal to minus 1. And we simplify further. We get the final expression as this. This is the final answer. In this problem, we have to show that if x minus iy is equal to square root of a minus ib by c minus id, then we need to show that x square plus y square the whole square is this expression. So how do we proceed such problems? We see that here we have to get x square plus y square and we have x minus iy here. If we multiply x minus iy into x plus iy, we get the term x square plus y square. So first we need to get x plus iy. How do we get that? So if x minus iy is this, x plus iy will be negating the I value in this. So this will become a plus ib by c plus id square root. That's what x plus I will be. X plus iy will be square root of a plus ib and c plus id. We have changed the sign of imaginary parts because here also we have changed the sign of the imaginary part. Now we multiply 1 and 2 so that we get x square plus y square. So x minus I and x plus y, we multiply these two. So on simplifying we get, and putting I square as minus 1, we get x square plus y square equal to square root of a square plus b square by c square plus d square. Now we need to get square here also because we have to prove x square plus y square the whole square. So now taking square on both sides, we get x square plus y square the whole square equal to a square plus b square by c square plus d square. This is what we wanted to prove. If z1 is equal to 2 minus I and z2 equal to 1 plus I, find mod of this. This two vertical lines we call it as mod or modulus of z. So for any complex number z equal to x plus iy, mod of z or modulus of z is given by mod of z. This is the symbol and it is equal to square root of x square plus y square. So first we have to evaluate this and put it in the form x plus iy. Once we have found this in the form x plus iy, we will take the square root of the x and imaginary and real parts and we get this the mod z. So how do we do it? We substitute the value of z1 and z2 as these. So we simplify this and get it as 2 by 1 minus I. Since you have to put in the standard form, we rationalize it by multiplying 1 plus I. 1 minus I is 1 square minus I square and I square is minus 1. We simplify and get z1 plus z2 plus 1 and z1 minus z2 plus 1 as 1 plus I. Now we need to find mod of this. So that will be equal to mod of 1 plus I, which is square root of 1 square plus 1 square. That's all. Real part is 1, imaginary part is also 1. So it will be square root of 1 square plus 1 square, which is square root 2. In this problem, a plus ib is equal to x plus I the whole square by 2x square plus 1. We need to show that ax square plus b square is this expression. So how do we proceed? What we will do in this problem, we will simplify this and get the real and imaginary parts of this expression. The real part will be equal to a and the imaginary part will be equal to b. So we'll get a and b from this, solving this. So once we get a and b, we'll plug in this expression and try to prove it to be the RHS. So let us simplify this. X plus I the whole square by 2x square plus 1. This will be, can be written in a plus b the whole square form, which is x square plus I square plus 2xi. That's all, and I square is minus 1. We simplify this as x square minus 1 by 2x square plus 1 plus I 2x by 2x square plus 1. Now this is a plus ib. So this is the real part. A will be this and b will be this. This is the real part, this is the imaginary part. Real part is a and imaginary part is this. So we put it, a will be put as x square minus 1 by 2x square plus 1. Comparison. Two complex numbers are equal only if their real and imaginary parts are equal. That's what we know. So since they are equal, real parts will be equal and imaginary parts will be equal. So a and b we have got. Now we put it as a square plus b square we want to determine. So we'll square a square and b square and simplify. We keep simplifying this and get this as the expression. This will be x square plus 1 the whole square. This particular expression denominator is already 2x square plus 1 the whole square. So once we simplify, we get this as the final answer which we needed to prove. In this problem, we are given z1 is 2 minus I, z2 equal to minus 2 plus I. We want to find real part of z1 into z2 by z1 bar. What is z1 bar? Is the conjugate of z1. So if any complex number z equal to a plus I by, its conjugate is given by z bar, which is equal to a minus ib. It means conjugate means we have to change the sign of the imaginary part of the complex number. Let us find this now. Let z1 is given as 2 minus I, z2 is minus 2 plus I. So z1 bar will be 2 plus I, changing the sign of the imaginary part. So now we multiply this z1 into z2 by z1 bar and get the real part. So we multiply this z1 into z2 by z1 bar. So this will be 2 into minus 2 plus I and minus 1 into minus 2 plus I. We keep simplifying and putting I square as minus 1. We get the expression minus 3 plus 4I by 2 plus I. But to get the real part of this expression, we need to put this in the standard form. How do we get? We now multiply both numerator and denominator by 2 minus I. Keep simplifying and put I square as minus 1. We get z1 into z2 by z1 bar as minus 2 by 5 plus I into 11 by 5. We have to find the real part of this. So the real part is only minus 2 by 5. This is the final answer. This is the final answer. Find the real numbers x and y if x minus iy into 3 plus y is the conjugate of minus 6 minus 24i. So what is conjugate of this? Conjugate of this is keeping the real part as it is or changing the sign of the imaginary part. So conjugate of this will be minus 6 plus 24i. And now minus 6 plus 24i is the product of these two. That's what is given here. So minus 6 plus 24i is equal to x minus iy into 3 plus 5i. So we are multiplying this two. We simplify and we put I square as minus 1. On simplifying we get and taking the real parts, combining the real parts and separating out the imaginary parts, we get minus 6 plus 24i as 3x plus 5y plus minus 3y plus 5x into I. The real part is 3x plus 5i is minus 6 and imaginary part is minus 3y5 plus 5x is 24. So we got two equations. So we can solve these two linear equations with two unknown variables. We get x equal to 3 and y equal to minus 3. This is the final answer. In this we want to find the modulus of this expression. We know that for a complex number x plus y, mod of z is given by square root of x square plus y square. So we need to first simplify this and put it in the form x plus iy. So we simply take the expression LCM 1 minus I into 1 plus I, then cross multiply, put I square as minus 1. We get 1 plus I by 1 minus I minus 1 minus I by 1 plus I as 0 plus 2I. So what is mod of this expression now? Mod of this will be square root of 0 square plus 2 square, which is square root of 4, which is 2. This is the final answer. In this problem, we need to show that u by x plus v by y is equal to 4 into x square minus y square, where x plus iv the whole cube is equal to u plus iv. What we will do in this problem, we will simplify this expression and then compare with u plus iv. So on left hand side we will get a complex number, and right hand side also one complex number is there. So real and imaginary parts we will equate. So a plus b the whole cube is a cube plus b cube plus 3ab into a plus b. So we now simplify this x plus iv the whole cube. Put I square as minus 7. We keep simplifying and get x cube minus 3xy square 3x square y minus y cube into I. So this part we have simplified to this. This is equal to u plus iv. Now we equate the real part. Real part is x cube minus 3xy square, and this is the imaginary part. So this is what we have equated. On simplifying, this x can be taken common here, so this will become u by x equal to x square minus 3y square. Similarly here 3x square minus y square will be v by y. Now we add 1 and 2. So we get u by x plus v by y equal to 4 square minus 4y square. That's what we wanted to prove. This is required to be proven, and we have done so. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.